Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. Today I had a Year 9 student send through this question here that they're looking for help with. What they sent through said $18,000 at 14% per annum for 2 years, compounded 6 monthly. So technically there's not a question there, but I'm going to work on the basis that the question wants us to calculate what this $18,000 would become if it earns interest for 2 years at this 14% per annum rate, compounded 6 monthly. So that's often referred to as the future value. So the 18,000 we'd call the present value, the amount we've got now in the present, and we're looking to calculate the future value. Now, with financial mathematics questions like these, a lot of the complexity can come through the terminology that can often be quite confusing. And some of the terminology we need to think about here comes down to this interest rate that we're given. And the format of the rate as it's been given to us is what's called a nominal rate. And essentially what that means is even though we've been given the rate as a per annum, 14% per annum or per year, because it's compounding at a different periodicity, in this case 6 monthly, we know that this is a nominal interest rate. And so I'll just note that the nominal interest rate is 14% per annum. The next thing we can do is we can convert that into a periodic interest rate. And the way you can think about that is we take our frequency of our compounding and we kind of work out, well, what would the periodic rate be such that if you then multiplied it by this frequency, you'd get to this nominal annual rate. So in our case, that would be, well, 6 monthly is the same as half yearly. So in other words, a compounding happens twice a year, every half year. So what times 2 gets you to 14? Well, that's 7%. So our periodic rate would be 7% per, I'll say per half year. It's probably easier than saying per 6 months. So we've got a periodic rate of 7% per half year. And finally, the third way we can think about the interest rate is what's called the effective rate. And the effective rate is essentially what interest rate do you effectively earn per year. So it's not actually 14%, interestingly. It's going to be something slightly different. And there's a certain formula we can use to calculate that effective rate. And in this case, what we do is we take 1 plus the periodic rate. So in our case, that's plus 7%. And then we take it to the power of the number of compounding periods per year. So because we're compounding every half year, every 6 months, that means the compounding periods is 2, because the compounding happens twice per year. So that's to the power of 2. And then we subtract 1. So if I just plug that into my calculator, we'll get 1.07 squared minus 1. And that's 0.1449. I'll just multiply that by 100. So that's 14.49% per annum. And that's effective. So now that we've kind of thought about the 3 ways in which we can refer to this interest rate, we've now actually got 2 options for calculating the future value. We could either calculate it using the periodic rate, or we could calculate it using the effective rate. And the key with either, we'll get to the same answer regardless of which one we use, but the key is to make sure that whichever rate we choose, the term, the amount of time that we apply it, is consistent. So if we're going to use the periodic rate, which is a half yearly rate, then we need to convert our term into half years. If we're going to use our effective annual rate, then we keep our term in years because then the years match the annual nature of the rate. So what I'll do here is I'll actually work through both approaches because then we can check that we get the same answer, which is a good way to ensure that we haven't made any mistakes. So for approach 1, what I'll do is I'll use the periodic rate. And this is probably the more common approach to use, simply because you don't need to do this extra step of calculating the effective rate. You can kind of stick with what you're given. So here, the future value would be equal to our present value, so that's the 18,000 we're starting with, multiplied by 1 plus the periodic rate, so 1 plus 7%. And we need to do it to the power of the number of periods, but here the number of periods is the number of half years. So if we're going for 2 years, then that's actually 4 half years. So it'll be to the power of 4, and that's what we'll use to get our future value. So we'll go 18,000 times 1.07 to the power of 4. And that gets us $23,594, and I'll round that to 2 decimal places, so 33 cents to 2 decimal places. And typically, if I'm not told the number of decimal places to round to, if I'm dealing with dollars, just as a convention, I'll typically just do it to 2. If you're told to do it to some other amount, that's fine. If you leave it unrounded, that's probably going to be fine too. But just as an old habit, just because with money we don't really go less than cents most of the time, I'll leave it in dollars and cents. So that's approach 1. Now let's look at approach 2. And the real key here is just to make sure we get the same number. So here I'm going to stick with the annual periodicity. So here our future value will be equal to, still we start with the 18,000, the amount we're starting with is the same, but now we're going to do times 1 plus, and here we'll use our effective annual rate, which was 14.49%. And because we're using an effective annual rate, we'll do it to the power of the number of years, in this case 2. So if I plug that into my calculator, we get 18,000 times 1.1449 squared equals 23,594.33. That is the same answer, so that gives us some confidence that we haven't made a mistake. I mean, it's possible that we could still have made a mistake and we just did it consistently, but I'm pretty confident this is the answer that we need to get to. And just doing that sense check just gives you a little bit more comfort. So hopefully you found that explanation helpful. I think the key to this question was just being careful with the terminology and understanding that there's 3 different ways that you can refer to an interest rate. And in this case, we've been given a nominal rate. So a common mistake, I think, here would just be to use 14% in this formula. Or most likely the mistake would be to use 14% here and do it to the power of 2 years. That would be a mistake. It's actually interesting kind of in the real world when you're having interest rates quoted to you. Often interest rates are quoted to you as nominal rates. And no one actually tells you that. It's not like a credit card company will tell you, hey, the interest rate is 14%, and by the way, that's a nominal rate, so make sure you do your conversions. They're not going to hold your hand in that way. The expectation is that you can work it out yourself, but I think the reality is that most people can't. Either they haven't learned this, or they've learned it so long ago in school and they've forgotten it, that they kind of end up with the wrong answers, I guess, when they're trying to do their own finances. So I think financial mathematics, it's a really important area of mathematics to get comfortable with. A lot of the complexity, I think, is contrived. It's actually driven by the companies who are lending out money wanting you to be confused so that you can't really understand what's going on, because I think they make more money that way. So I think as a student, someone who's learning this, I think hopefully that can be a motivation to really try and get your head around it and get comfortable with it, because in the end you'll probably end up saving money and not getting kind of scammed in the future. So there you have it. If you found that explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, please be sure to subscribe to my channel so that you can stay in the loop. Alright, tick boom.